Cisco Packet Tracer Software User Guide. What is Cisco Packet Tracer? Cisco Packet Tracer is a powerful network simulation tool designed by Cisco Systems. It enables users to create network topologies, configure devices, and simulate network behavior. This software is particularly useful for networking students and professionals to practice and understand complex networking concepts in a virtual environment. Router. A router is a network device that forwards data packets between computer networks, directing traffic on the Internet. It connects different networks, such as a local area network, LAN, to the Internet, and determines the best path for data to travel. Routers use routing tables and protocols like RIP, OSPF, and BGP to make forwarding decisions. They also provide features such as network address translation, NAT, firewall security, and quality of service (QoS) management to ensure efficient and secure data transmission across diverse network environments. Switch. A switch is a networking device that connects multiple devices within a local area network, LAN, and uses MAC addresses to forward data only to the specific device for which the data is intended. Unlike hubs, which broadcast data to all devices, switches reduce unnecessary traffic and improve network efficiency. Switches operate at the data link layer, Layer 2, of the OSI model but can also provide Layer 3, network layer, functions. They support features like VLANs, trunking, and port mirroring, making them essential for managing and segmenting network traffic in both small and large networks. Server. A server is a powerful computer that provides services, data, and resources to other computers, clients, on a network. It hosts applications, manages data storage, and handles requests from client devices. Servers can run specialized software such as web servers, email servers, database servers, and file servers. They are designed to operate continuously, ensuring high availability, reliability, and security. Servers often have robust hardware configurations, including multiple CPUs, large amounts of RAM, and redundant power supplies to handle heavy workloads and ensure optimal performance in enterprise environments. Learning process. 1. Getting started. Times installation. Download and install Cisco Packet Tracer from the Cisco Networking Academy website. Version 8.2.1.0118. Times User Interface Overview. Familiarize yourself with the main components of the interface, including the toolbar, device list, workspace, and output console. 2. Basic network creation. Creating a basic network in Cisco Packet Tracer involves several key steps that enable users to understand fundamental networking concepts and how different devices interact within a network. This section will provide detailed guidance on adding devices, connecting them, and configuring their settings. Adding devices. 1. Device types. Times end devices. These include computers, laptops, servers, and smartphones. End devices are typically the source or destination of network communication. Times networking devices. These include routers, switches, and wireless access points, which facilitate data movement across the network. 2. Adding devices to the workspace. Times selecting devices. In the device selection box at the bottom of the Packet Tracer interface, click on the device type, example, routers, switches, end devices. Times dragging and dropping. Drag the desired device from the selection box and drop it into the main workspace area. Repeat this process to add multiple devices. Connecting devices. 1. Understanding connections. Cables. Cables are essential for connecting and transmitting data between network devices. Common types include 1. Ethernet cables. Times copper straight through, used for connecting different devices, example, PC to switch. Times copper crossover, used for connecting similar devices, example, switch to switch. Times category 5E, Cat 5E, and category 6, Cat 6 support higher speeds and reduced interference. 2. Fiber optic cables. Times single mode fiber, SMF suitable for long distance communication. Times multi-mode fiber, MMF suitable for shorter distances, such as within a building. 3. Serial cables, used for long distance, low-speed connections, often in older networking equipment. 4. Console cables, used for configuring network devices via a computer's serial port. These cables ensure proper connectivity and data transmission within various network setups, supporting both wired and wireless environments. Types of connections, use different types of cables depending on the devices being connected. Common cables include copper straight through, copper crossover, fiber optic, and serial cables. Port types, devices have specific ports such as Ethernet, Fast Ethernet, Gigabit Ethernet, serial, and console ports. Ensure you connect the correct ports to establish a proper link. Port. Network devices and computers use various types of ports to connect and communicate with each other. These ports can be categorized into physical ports and logical ports. Physical ports. 1. Ethernet ports. Fast Ethernet, 10 by 100 Mbps, commonly used for local area networks, LANs, supporting speeds up to 100 megabits per second. Gigabit Ethernet, 10/100/1000 Mbps, supports speeds up to 1 gigabit per second, providing faster data transfer rates for modern networks. 10 gigabit Ethernet, used in high-performance network environments, supporting speeds up to 10 gigabits per second. 2. Serial ports. Rupees 232, an older standard used for connecting modems and other devices, often used in legacy systems. USB to serial adapters that allow serial communication via USB ports. 3. Fiber optic ports. Single-mode fiber, SMF, used for long-distance communication with smaller core diameters. Multi-mode fiber, MMF, used for shorter distances with larger core diameters. 4. Console ports. RJ45, used for device management and configuration through a console cable, often found on routers and switches. Mini USB, USB Type-C, modern alternatives for console connections on newer devices. Logical ports. Logical ports are virtual communication endpoints that enable networked devices to interact with specific services and applications. These ports are identified by numbers ranging from 0 to 65535 and are managed by the operating system. 1. Well-known ports. 0 to 1023. HTTP, port 80, used for web traffic. HTTPS, port 443, used for secure web traffic. FTP, port 21, used for file transfer protocol. SSH, port 22, used for secure shell access. 2. Registered ports. 10244951. Assigned to specific services and applications by the Internet Assigned Numbers Authority, INA. MySQL, port 3306, used by MySQL database servers. Microsoft SQL Server, port 1433, used by Microsoft SQL Server. 3. Dynamic or private ports. 49152 to 65535. Used for ephemeral or temporary connections. typically assigned by the operating system for client-side communications during session initiation. Summary: physical ports, physical interfaces on network devices and computers, example, Ethernet, serial, fiber optic, console ports, used to connect hardware and transfer data. Logical ports, virtual endpoints, example, HTTP on port 80, HTTPS on port 443, used by networked devices to access specific services and applications. Understanding both physical and logical ports is crucial for network configuration, troubleshooting, and ensuring secure and efficient communication between devices. Times router to router. Routers need to be implemented by physical by clicking the router, switch off the router adds WIC to T and switch on the router to add the serial DT connection between routers. 2. Connecting devices. Times selecting the connection tool, click on the connections icon in the toolbar, which resembles a lightning bolt. Times choosing the cable type, select the appropriate cable type for your connection. For example, use a copper straight-through cable to connect a PC to a switch or router. Times making connections, click on the first device, select the port, then click on the second device and select the corresponding port. This will establish a connection between the two devices. Times verifying connections. Once connected, you should see a green linked indicator on both devices if the connection is successful. If not, troubleshoot by checking the cable type and port configuration. Configuring devices. 1. Accessing device configuration. GUI configuration. Click on the device to open its configuration window. For end devices like PCs, this window will allow you to configure basic settings through a graphical interface. CLI configuration. For networking devices like routers and switches, you can also use the command line interface, CLI, to configure settings. 2. Basic configuration steps. IP address. An IP address, Internet Protocol address, is a unique identifier assigned to each device connected to a network. It serves two main purposes: identifying the host or network interface and providing the location of the device in the network. IP addresses can be either IPv4, example, 192.168.1.1, or IPv6, example, 2001, 0db8, 85 a 3, 0000, 0000, 82e, 0370, 7334. IPv4 addresses are 32-bit numeric addresses written in decimal format divided into 4 octets, example, 192.168.1.1. IPv6 addresses are 128-bit alphanumeric addresses written in hexadecimal format divided into 8 groups of 4 hexadecimal digits, example, 2001, 0db8, 85 a 3, 0000, 0000, 82e, 0370, 7334. Each IP address has two parts: the network portion, which identifies the network, and the host portion, which identifies the device within that network. Subnet mask. A subnet mask is a 32-bit number used in IPv4 networking to divide an IP address into network and host portions. It determines which part of the IP address corresponds to the network and which part corresponds to the host. For example, the subnet mask 255.255.255.0 used with the IP address 192.168.1.10 means the first 3 octets, 255.255.255, are the network part. The last octet, 0, is the host part. This subnet mask allows for 256 IP addresses, 192.168.1.0 to 192.168.1.255 within the network, where the first address is the network address and the last address is the broadcast address. Gateway address. A gateway address is the IP address of a network's default gateway, which is a router that connects the local network to other networks, often the Internet. The gateway acts as an intermediary that passes data between different networks. For example, in a home network with the IP address range 192.168.1.0/24, the default gateway might be 192.168.1.1. This router forwards traffic from devices on the local network to external networks and vice versa. In summary, IP address identifies a device on a network. Subnet mask divides the IP address into network and host parts. Gateway address, the router that forwards traffic to other networks. IP address configuration, assign IP addresses to devices to enable communication, both by manual putting options and by code also. The code details are provided below in the box. For a PC, open the configuration window, go to the Desktop tab and select IP configuration. Enter the IP address, subnet mask, and default gateway. Subnet mask and default gateway ensure that each device has the correct subnet mask and default gateway configured for proper routing. Hostname configuration, set hostnames for devices to easily identify them in the network. 3. Verifying configuration. Ping. In Cisco Packet Tracer, the ping command is used to test the connectivity between devices within a network. It sends ICMP, Internet Control Message Protocol, echo requests to a specified IP address or hostname and waits for an ICMP echo reply. The response time, round-trip time, indicates the network latency between the sender and receiver. The ping command helps network administrators diagnose connectivity issues, verify network reachability, and troubleshoot network problems by confirming whether a device can communicate with another device successfully over the network. It's a fundamental tool for assessing and maintaining network health and performance. Times ping test, use the ping command to verify connectivity between devices. Open the CLI of a device and enter. By following these steps, students can create a basic network in Cisco Packet Tracer, which lays the foundation for more advanced networking tasks. This hands-on practice helps solidify understanding of network fundamentals and prepares students for real-world networking scenarios. 3. Intermediate networking tasks: routing and switching. Configuring routing protocols. 1. Routing Information Protocol, RIP. Times RIP overview. RIP is a distance vector routing protocol used in small to medium-sized networks. It uses hop count as a metric to determine the best path to a destination. It can be done by simple manual putting in the RIP section of router under Config tab as shown in the figure below, and also by code which is shown in the box section. Times configuration steps. Times access the router's CLI and enter global configuration mode. Times enable RIP routing protocol. 2. Open shortest path first, OSPF. Times OSPF overview. OSPF is a link state routing protocol used in larger and more complex networks. It uses the Dijkstra algorithm to calculate the shortest path. Times configuration steps. Times enter OSPF configuration mode in the router's CLI. Times define OSPF areas and assign interfaces. Switch configurations. 1. Virtual Local Area Networks, VLANs. Times VLAN overview. VLANs segment a physical network into multiple logical networks, improving security and reducing broadcast traffic. Times configuration steps. Times access the switch's CLI and create a VLAN. Times assign switch ports to the VLAN. 2. Trunking. Times trunking overview. Trunking allows VLAN traffic to pass between switches. Trunk ports carry traffic for multiple VLANs. Trunk will work when no routing protocol is used. When router is present, then inter-VLAN will work. Times configuration steps. Times set a switch port as a trunk port. By configuring routing protocols and switch settings like VLANs and trunking, students can manage traffic efficiently, improve network segmentation, and enhance overall network performance. Times wireless networks. Simulate wireless networks by adding and configuring wireless devices. Times network services. Implement network services such as DHCP, DNS, and HTTP servers. 4. Advanced network simulation. Times security configurations. Set up firewalls, access control lists, ACLs, and VPNs. Times complex topologies. Create complex network topologies involving multiple interconnected networks. Times troubleshooting. Use simulation mode to troubleshoot network issues and understand packet flow. 3. Summary. Cisco Packet Tracer is an invaluable tool for networking education, enabling users to simulate, configure, and analyze network environments. The user guide covers the essentials, starting with basic network creation, where students learn to add devices, establish connections, and configure settings. This foundational knowledge includes assigning IP addresses, configuring subnet masks, and setting up default gateways, providing a solid grounding in network fundamentals. Moving to intermediate networking tasks, students gain deeper insights into routing and switching. They configure routing protocols like RIP and OSPF, understanding how data is routed across networks efficiently. Additionally, switch configurations such as VLANs and trunking are explored to segment networks logically and manage traffic effectively. Through hands-on practice with Packet Tracer, students can visualize network behavior, diagnose issues using troubleshooting tools, and collaborate on complex network setups. This comprehensive approach ensures they grasp both the theoretical and practical aspects of networking, preparing them for real-world scenarios. Whether configuring a simple home network or a complex enterprise system, Cisco Packet Tracer provides a robust platform for learning, experimentation, and skill development, making it an essential resource for aspiring network professionals.